Good morning, my fellow scientists. My name is Alex and I'm an educator here at the Emerald Coast Science Center. Today I have a really cool experiment that we're going to do, as well as a really interesting lesson behind it all. We're going to be doing Oobleck Ooze today. This is an experiment that my mother taught me when I was young, and I sort of carried it throughout life with me. So hopefully it's something that you'll look back on with fun. It's kind of like I do. So to start off with, we're going to learn some vocabulary, do the lesson, and then the messy stuff will be at the end. That way we don't have to worry about touching things and worrying about learning the words. So as you might notice, I do have some larger words on the board behind me. I know that they look a little bit scary and intimidating, but we are going to go ahead and challenge ourselves. As scientists, we challenge ourselves every day to learn new things. We challenge each other. So my challenge for you today is to go ahead and pronounce some of these words at home, maybe memorize them over time. But these words do contribute to the lesson that we're going to be doing today and help you understand the experiment even better. So our first word is going to be viscosity. So viscosity is the state of being thick, sticky, and semi-fluid in consistency. So that means that the thickness of a liquid. If a fluid is more viscous, it's going to be thicker. So I usually like to think of honey compared to water. Honey, if you try to squeeze it out of the bottle, it's a little bit, it flows slower. And compared to water, water will just slosh around. So honey is more viscous than water. So when it comes to the viscosity, you can have a Newtonian fluid or a non-Newtonian fluid. So a Newtonian fluid is a fluid whose viscosity remains the same despite any force or pressure being put on it. A non-Newtonian fluid is quite the opposite. So it's a fluid whose viscosity changes as a result of any pressure or force that we put on it. Under non-Newtonian fluids, you can have two different classifications. You can have a dilutant, aka a shear thickening fluid, or you can have a pseudoplastic, which is a shear thinning fluid. So dilatant fluids, as pressure increases, so does the viscosity. Whereas pseudoplastic, as pressure increases, viscosity does tend to thin down. So a good example of a dilatant fluid would be beach sand. The ocean grabs it, it flows it, and takes it out to sea. It looks like it's a nice, smooth liquid, but as soon as you go to step on that wet sand, you might notice that you're squeezing some of that water out with your foot. You might notice a little bit of coloration change around your foot, just because you are squeezing that water particles out of it. So that is a dilatant fluid because you're adding that pressure from your foot in order to make it more solid under your feet so that it's easier to step on. Another example of dilatant fluid would be silly putty. Sometimes you might have silly putty at home, you stretch it, it seems to kind of flow a little bit better, but as soon as you put it into a tight, compact ball, it's going to be a little bit harder to squeeze and pull apart. As for pseudoplastics, these ones you would consider things like ketchup, mayonnaise, and even blood. So again, that thickness is getting thinner as more pressure is applied. So I have an example here for you. It is ketchup. So this ketchup is the same brand. It's had the same treatment. It's not been altered in any way, and it's been kept under the same conditions as we want all science experiments to do. So my control is this cup here, cup A. So I haven't done anything to it. We're just going to let it sit and remain. Whereas we have cup B here. The force that we're going to exert on it is when we stir the ketchup. So that pressure puts it on there. It makes it a little bit smoother. If I stir it up a bit, make sure that you guys can kind of see the sides. And you might notice that it flows quicker than cup A. So as I push it, and you can try these at home as well, see what results that you get, and you can also change those parameters just as any experiment does. We want to alter it and change it in our own ways, but this is a really simple thing to explain pseudoplastics. So hopefully you guys got to see how that one moved a bit faster than cup A. So we're going to do our experiment now. We are going to use our cornstarch and our water. I know that we put 2 cups yesterday in preparation. Parents, you might want to use a little bit less just because that is a lot. So I am just going to use 1 cup today and half a cup of water. So you do want a 2-to-1 ratio. You can add more if you want, or add less if you want smaller batches. But just keep that 2-to-1 in order to make sure that we're keeping up on it. You do want a nice surface that you can easily clean afterwards because This can be difficult to get off. If it does manage to get on a surface or a carpet or anything like that, just scrub it with soap and water, and that should help get it out, but it can be a little bit of a pain. If you're wearing a nice shirt or anything like that, you might want to put an old shirt on, or perhaps an apron. So I'm going to be putting on an apron today, just to make sure I protect my clothes, and it's okay if kids want to do that as well at home. It does come out in the wash very easily. However, like I said, if you're trying to get it off right now, it can be a bit hard to scrub, and you might spread it around. So I already have these pre-measured out. So this is 1 cup of cornstarch. I'm just going to go ahead and pour on in here. And then I'm going to go ahead and pour my 1/2 cup of water. So I'm going to mix those together and just stir them a little bit. You can add food coloring or tempera paint. Tempera paint won't stain your skin quite as much as food coloring does. But if you are going to use some food coloring, I recommend stirring with a spoon first. That way it doesn't get all over your hands and stain quite as much. If all you have at home is gel food coloring, that's perfectly fine. That works as well. So I'm just going to add just a small drizzle. And I'm going to mix that in. Now you might notice it's a little bit difficult to stir with the spoon. Just keep going until you get that food coloring mixed in. And then go ahead and use your hands. I told you it could be a little bit messy. And so if your consistency seems too gooey or runny, go ahead and add a little bit more cornstarch. And if it seems too powdery or rough, go ahead and add some more water to make it a little bit more liquidy. However, you are going to want a thick consistency that allows you to rip it. So this one might be a little bit too cornstarchy, so I can go grab some more water real quick. So you are going to want to add just a little bit until you reach that consistency, because you can overshoot it if you add too much water. I feel like we should have some music playing in the background. Alrighty, we are almost there. So as you grab it, you are going to want to see it kind of rip a little bit as you pull your finger through. So again, this, like I said, it is messy, so it might toss up on you. But you can see that it's ripping as I grab it. And so what's really cool about this is you can see that as you put more pressure on it, it does become more solid. You can grab it with your hands, you can pick it up, put it into a nice thick ball like that, and it kind of stays, and then all of a sudden you just let it go, and it drips. It becomes more liquidy. So does this make it a dilatant fluid or a pseudoplastic? Do you guys know? So if you said dilatant fluid, you would be correct, because I am adding more pressure, and so it becomes more thick or more solid in my hands. And so you can play with this a little bit. What I like to do is I like to take a toothpick. Let's see, get this off my hands a little bit. And it can stick to your hands. That's perfectly fine if it's sticking to your hands. That's what it does. You can pull it off. It'll come off in little solid pieces, or you can just let it drip off. So when I poke this, you can see that it's kind of moving like a water or a liquid right in that bowl. But as soon as I poke it, you can see that there's some pushback. I don't know if I have the right angle, I'm sorry. You can see that there's some pushback when you poke a Q-tip, or even just your finger, you might notice as well. But you can try a variety of objects putting in there. but they will come out messy, so make sure that you're not putting any of your favorite plastic toys or anything like that in there. But you can go ahead and play with that as much as you want. Now is a good time to mention that this is not like sugar and water where sugar dissolves and creates a solution. The cornstarch will separate from the water in time if you give it enough time. So it is important that you don't discard it down the drain. If you're going to throw it away, make sure you put it in the trash, just because mass amounts of cornstarch can clog your drains. It's okay to rinse your hands under it. It's just a small amount and it'll get pushed through with the water. Just make sure that you're not putting large amounts. This does keep really well in a closed container or a plastic bag. You just might need some help getting it in there. If you guys have any questions, feel free to ask. But our center is currently closed still due to the coronavirus, but we do ask that you tune in tomorrow at 10 a.m. We've got some really cool animals to show you. And we'll be doing this all next week as well. We're doing Facebook Live at 10 a.m. each weekday. Got some more cool experiments for you, some really cool animals. In the meantime, if you want to continue to support us while we are closed, you can become an animal ambassador. You can sponsor a little scientist with different projects, and you can even buy a membership here to enjoy fun all year long. If you guys have any questions about this experiment or just want your voice to be heard, go ahead and comment on this and we'll be sure to get back to you in a timely manner. But otherwise, you guys have a good day.